All right, here with section 2 now. Um, Hopefully section 1 wasn't too much of a problem trying to figure that one out. There's a lot of material here in section 1 and 2 and 3 and 4. So thankfully it's a short chapter because we do have a lot to get to and a lot to learn. So let's go ahead and start in with section 2. We're still graphing quadratic equations, but this time we're going to use those graphs to be able to solve them, meaning we're going to find the answers, what x is equal to. Okay? So remember last section we factored trinomials ax squared plus bx plus c. Okay? A is in front of x squared, b is in front of x, and c is added and subtracted at the end. Okay? And just like solving equations by factoring, what we did right at the end of chapter 8, where we had the equation equal to 0, and then we factored it, and we took those factors and set those equal to 0 and found the answers. Okay? In order to solve those, we needed it to be equal to 0. In order to solve them by graphing, we still need it to be equal to 0. Okay? So make sure whenever you go to graph these that our equation is equal to 0 first. Then graph it, then we can find the solutions. And we'll see here in just a minute. One of the names for these solutions are called roots. Okay? So the solution to a quadratic equation is called a root. Okay? Another name for that is called a zero. And that's probably the one I'll end up using the most. It might say roots on the paper because that's the one that the book uses a lot. But most of the time when I talk about them, I call them zeros. Okay? But just know that a root and a zero is the same thing. They're both solutions to a quadratic equation. The reason one of them is called a zero is because it's the x-intercept. All right? We're looking at where it crosses the x-axis are the solutions. And so it's crossing the x-axis at 0 when x is equal to 0, which means it's an x-intercept. X is zeros, so zeros are solutions. All right? So hope that we can keep those two things straight. Whether I ask for a root or for a 0, I'm asking for the same thing, just the solutions to the quadratic equation. So let's start with example 1 here. All right, we can take the shortcut to graph this. Hopefully you took the time to learn how to do that because it's going to save you a lot of time and energy here. We're going to use the opposite of b over 2a, find the middle of this quadratic equation. All right, so negative 4 over 2. The x value for the vertex is negative 2. Then we take that and we plug it in for x to figure out our y coordinate for the vertex. So negative 2 squared plus 4 times negative 2, if I can write better, minus 5. Negative 2 squared is 4. Negative or positive 4 times negative 2 is negative 8 minus 5. 4 minus 8, negative 4 minus 5 equals negative 9. So I take those, and that is the vertex, negative 2, negative 9. So let's go over here and graph this. Negative 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. Negative 9. Okay. Then remember we can look in front of our x value, x squared value, sorry, for our slope, and I use slope in quotation marks because it's not really a slope, but it's kind of like a slope. And since it's 1, it's telling me to go up 1 and over 1, up 1 and over 1, and there's the start of our parabola. So then you can see as it curves up, it's going to cross the x-axis. As this curves up, it's going to cross the x-axis. Okay, and the answer to our problem, to this equation, is where it's crossing the x-axis. So right here and right here. Now, I hope some of you are noticing a problem with this form. Those are our solutions. Okay, what's the problem here? The problem is that we don't know exactly where it's crossing. Okay, it's very difficult to see, especially on our handmade graphs, because we're humans. We make mistakes on the spacing between the points and the angle that the parabola goes up at. Okay? So we can't tell. That's the big problem with trying to solve equations through graphing, is that you can only guess about what it's going to be. Okay? One of the solutions is x is about 0. And this solution, x is probably about 5 or 6 maybe, somewhere in there. Okay, but there's no way to really tell. So all I'm going to ask you to do is draw the graph and then circle where it's crossing the x-axis, and that'll be good enough for the solutions. Okay? So I hope you were listening, otherwise none of that's going to make any sense. So I ask you to please make sure you're listening to this, not music, and listening to me talk. I know it can be boring, but it's only 10 to 15 minutes. Right? Now, special note here, quadratic equations always have two roots or two zeros. Okay? They always have two solutions, and you'll see in the future in Algebra 2, maybe pre-calculus somewhere in there, that a equation always has, or a polynomial always has the same number of solutions as the largest exponent. Since our largest exponent in quadratics is a 2, we have two zeros, roots, solutions, whatever you want to call it. Okay? So now let's take a look at example 2. And like I said at the beginning, the very first thing we need to do is make sure our equation is equal to 0. So I'm going to add 9 to both sides. Make sure you're careful not to do negative 6 plus 9 because they're not like terms. Negative 6 plus 9, or negative 6x plus 9 cannot be added. One has an x, one doesn't. So we just have to write them next to each other. Now we can use the axis of symmetry, the opposite of b. So opposite of 6 is positive, negative 6 is positive 6 over 2a gives me 6 over 2, which is 3. If I plug that back in to the equation, I'll get 3 squared minus 6 times 3 plus 9. 3 squared is 9 minus 18 plus 9. Negative 9 plus 9 gives me 0. So now my vertex is at 3, 0. All right? So we'll go ahead and put this on here. And we see that right there is one of our solutions. Okay? Is at 3, 0, because we know that our solutions cross the y-axis or x-axis. So that has to be one of our solutions. Now if we use the, again, the quote-unquote slope, it tells me to go up 1 and over 1, up 1 and the other way 1. When we graph it, we see that the only place it's crossing the x-axis is right here at 3. That's the only place it's crossing. So we do know that x is equal to 3. Okay? But, like I said, there's always two solutions. Okay? What happens here is when you only have the graph crossing at one spot, it's what's called a double root. And if you're paying attention, you'd see that next to example 2 here, a double root. And that means that means 3 actually appears twice. Okay? Whenever we solve the solution out, we would end up getting 3 two times, which doesn't change the fact that x equals 3, but it just appears twice, so it's called a double root. Okay? And that's where the two solutions come from that you would get. All right. Hope we're keeping up. If not, feel free to pause it, as always. Catch up, re-listen to something. Now, if we look on the back, okay, entitled this one, Example 3, No Roots, and we're going to see something here. Start these all just the same. Opposite of b over 2a. So negative 2 over 2 is negative 1. Means my x part of my vertex is at negative 1. And if I plug that in, negative 1 squared plus 2 times negative 1 plus 3. I get 1 minus 2 plus 3. Negative 1 plus 3 is 2. So my vertex is negative 1, 2. All right, let's go ahead and graph this. Negative 1, 2. Now, some of you might already be noticing something different and seeing what's going to happen here. So now I use my slope to go up 1, right 1, up 1, left 1. And we should see something kind of funny here. Our graph is not crossing the x-axis anywhere. It started above the x-axis, it opened up, and so we can't really do anything. So what happens here is that we have no solutions. So you can write no solutions, no roots, no zeros, or you can just put 0 with a line through it, the empty set, because there are no solutions to this. Okay? Now, if you scroll down just a little, if I scroll down, if you look down just a little bit more, remember when we were solving equations using factoring, okay, this is a quadratic trinomial. We solved by finding what multiplied to 3 and added to 2. So if I try to figure those things out, the things that multiply to 3 are 1 and 3, negative 1 and negative 3. But when I add those, I get 4 and negative 4. So what happened when none of the solutions worked, or when I couldn't find anything that did that? We said it was prime. Okay? When I had the prime quadratic equation, that really means there's no solutions. There's nothing I can plug into x to make the equation true. Okay? So you see, anytime you have a prime quadratic, you also have no solutions. All right? So that wraps it up here for section 2, solving by graphing. Section 3, we're going to learn how to solve quadratics using a technique called completing the square. And in section 4, we're going to learn how to solve them using what's called the quadratic formula. Okay? Now, if you think back to when we were doing systems of equations, we were able to solve by elimination, by substitution, by graphing, all those different ways, and they all got you the same answer. It's the same thing here with quadratics. Okay? You can solve all of these by any method you choose, although some you cannot solve by factoring because they're prime, obviously, which means there's no solution. So you could try factoring. But where was I? Oh. Each one has its own kind of unique qualities. Like we talked about, graphing here is just an approximation, an estimate. You're never going to be able to find, not never, you're almost never going to be able to find an exact solution for quadratics when we're graphing. But completing the square and quadratic formula will always find exact solutions. So we'll see those two coming up here in sections 3 and 4. And so yeah, it's been great. We'll see you next time. Bye.